Hi, we're going to wrap up graphs and of polynomials, but today we're going to add in some imaginary solutions. So let's do a quick review. Given the graph to the right, find all the solutions of the polynomial. Well, we know that solutions are x-intercepts, right? So we can find two of them already. Not for sure because it counts by 2. So we only know 1. Okay, so this is x equals 1. Is one of our solutions. Well, let's take a moment and use the one we have to synthetic divide. So if we can use synthetic division, we absolutely should. Let's see, negative 2x cubed, x squared, x's, and numbers. Let's write that in on top just so that we can be sure we didn't miss a 0. Do that sometimes. And then we're going to take x equals 1 and use synthetic division. The problem right now is that these two are what we're looking for. Right? These are my other solutions. X equals. The problem being that they are fractions and we can't figure out what they are. So what we're going to do is do synthetic division. Bring down the negative 2, multiply outside numbers, add inside numbers, multiply outside, add inside, multiply outside, remainder should be 0. And we know it equals to 0 because it's a solution, right? So that means that we're heading in the right direction. If you didn't get a 0, you might have forgotten to keep the sign the same because this is x equals 1. Okay. So right now what this is we have negative 2x squared down from x cubed plus 1x plus 4, and our other factor, this one, is x minus 1. Okay. Well, there's no easy way to factor this. So how can I check that? And how do I know that? Well, I could do a times c. Okay, so if I tried a times c, what numbers multiply to negative 8 and add to 1? It's not possible. So this is not factorable. It doesn't mean you stop. If something is not factorable, we are going to use the quadratic formula. I'll do it over here. That's right. Not factorable means use quadratic formula. Okay, so I'll do that over here. Let's write the quadratic formula at the top, just in case you forgot it. There once was a negative boy who was unsure if he should go to a radical party, but the boy was too squared and lost his chance with 4 awesome chicks, and the party was all over at 2 a.m. So let's go from here. And a is equal to negative 2, b is equal to 1, and c is equal to 4. Negative 2, 1, and 4. So I'm going to go x equals negative 1 plus or minus the square root of 1 squared minus 4 times negative 2 times 4. All over 2 times negative 2 for a. And so let's simplify our terms. Negative parentheses 1 is just negative 1. Plus or minus 1, and then 4 times 2, negative 4 times negative 2 is positive 8, times 4 is positive 32 over negative 4. This is going to give us negative 1 plus or minus root 33 over 4. And there is no way to simplify root 33. If there was, we would keep going. Okay, so what does this mean? Well, technically, if you split it up, we're going to get negative 1 plus root 33 over 4, negative 1 minus root 33 over 4. But what does this mean, and how do we know if we are right or not? So let's take a moment. I'll take out my graphing calculator, and I'm going to here's the important thing. You have to put parentheses around the top, okay? So, or only do the top. So I'll do -1 plus square root 33. Your calculator does not have a plus or minus button. I'm going to hit enter because I want the whole thing divided by 4. If I do divide by 4 here, I'm only dividing the square root by 4, okay? So I'm going to delete those two. That's what I get, and I divide by 4. So one of our answers is approximately 1.19. Look, that's that one. And then if I do second enter, I can go back and change this to a minus divided by 4. And that gives me approximately -1.69, which is that one. Okay, so that's our final two answers, x equals and x equals. There was one more, find all the solutions. That is 1. Okay, so 3 solutions because there's an exponent of 3. So just a reminder, remember, fundamental theorem of algebra says that total number of solutions is equal to the degree. Well, let's keep going. Ready? Give me 1 second. So just to recap, we were doing the same thing, except that now if we can't factor, we use the quadratic formula. So let's move on to our next example. Based on the fundamental theorem, how many total solutions does this graph, which is shown on the right, have? Well, I know it has a degree of 3, so 3 solutions. But the problem here is that even though there's supposed to be 3 solutions, there's only one real solution that we can see on the graph. X-intercepts equals to real solutions. And we only see one x-intercept at x equals 2. It's not repeated, right? Like it's a line. So we're crossing right through it. There's no multiplicity. The multiplicity is 1, I should say. Okay. So what does that mean then? Well, if there's 3 total, and we know that one of them is a real solution, that means there's 2 unaccounted for. Those 2 are imaginary solutions. Okay, so if it never crosses the x-intercept, this is different than what we had up here as decimals. Decimals are not imaginary. Decimals are just like irrational. Okay, so I'm going to write here, irrational means that you have a radical in your answer, and it's going to be a decimal that goes forever. Imaginary means that you're not even going to have a radical. It means that here, if you do the quadratic formula, you're going to end up, or if you solve, you're going to end up with an I, a negative number under the square root. Let's take a look and see what to do. Ready? So here it tells you, use synthetic division to start factoring, then use the quadratic formula to find imaginary. If you can factor, you can also factor. So let's do it. This is one you have to be careful of. There's 1x cubed, 0x squareds, -2x, and -4. And then we have a solution of x equals -2, or sorry, x equals 2. So I'm going to use x equals 2 here. We should get a remainder of 0. And so now I have a new quadratic, which is x squared plus 2x plus 2. Okay, you should always try factoring if possible, but we know that there's no number that multiplies to 2 and adds to 2, so this is not factorable. Not factorable does not mean you're done. Once again, it means that you need to use the quadratic formula. Okay, so I have a equals 1, b equals 2, c equals 2. Negative b plus or minus square root of b squared minus 4ac. all over 2a. When you multiply negative 4 times 1 times 2, it's negative 8. That means you have negative 2 plus or minus root negative 4. We can simplify square root of negative 4. So that's going to be negative 2 plus or minus 2i root 2. Okay, so once we have this, we're going to split and rewrite this as a fraction, because this helps us realize that we can reduce each fraction, which gives us negative 1 plus or minus I. Okay, so those are my two solutions, and then I have one more, which is 3 solutions. Okay, let's keep going. So let's take a moment and just recap what we know. How do we know how many imaginary solutions a polynomial has? Well, you can take the total number of solutions, which is your degree, or number of terms, or the slopes, right? And you can subtract the number of real solutions, which is the x-intercepts. Be careful of multiplicity. Because that matters. That gives us number of imaginary. Now, one thing to keep in mind is, since we have to use the quadratic formula for imaginary, or you have to have a square root of a negative number, you're always going to have one positive and one negative, which means that imaginary solutions come in pairs. You will always have one positive I and one negative I, and you're never going to end up with a single one. Okay? So, total number of solutions. Let's take a moment and see. Total, real, and imaginary. 1, 2, 3. There are 3 degrees, right? So the degree is 3. Sorry, so there's a total number of 3 solutions. The number of real solutions is your x-intercepts, which is right here. So there's one of those. And when we subtract them, we know there has to be 2 missing imaginary solutions. Okay. Take a look at this one. We have 1, 2, 3, 4. It looks like there's only one real solution, but that's x equals 1 and x equals 1. The multiplicity is 2. Okay. Since the multiplicity is 2, there are 2 real solutions here. And we have the number, when we subtract these, we have the number of imaginary solutions is 2. Total number of solutions, 1, 2, 3, 4. Number of real, 1, 2. And the number of imaginary is the remaining one. So these always add up to total. Okay? So now we know how to tell how many imaginary solutions a polynomial has. Now we're going to find them all. Okay, so that's just like a quick check, and then we are going to find them. This is going to be exactly the same. You're going to use the x-intercept of the given graph. You're going to find the x-intercept of the given graph to find the real solutions, and then use the quadratic formula to find the other missing ones. Okay. So, let's try it out. So let's do synthetic division, right? So anytime you're given an x-intercept, that means we can keep going and use that. You also might be able to see that we could factor by grouping here. Do you see that? So if we can factor by grouping, that might even be faster than synthetic division. So let's try factor by grouping. This will just be x squared, sorry. This will be -2. Oh, I don't think my graph is right. Oh, no. Okay, this is awesome. So, herein lies the problem. So I can try x squared, and then when I divide by x squared, I have 2x left plus 1. And then I have -2, which everything is looking really good right now, but look at the problem now. Positive divided by negative is a negative. These do not match. That means this is not factorable. Okay, so I wanted to take a shortcut and it didn't work. So we have to do it this way. And then we're going to end up doing the quadratic formula. Wonderful. Now that I've wasted all my space that I wanted to use it. Let's see. -8, remainder of 0. This is A, B, and C. So I'm just going to go straight in because I'm running out of space. -3 plus or minus square root of b squared minus 4. A is 2, C is 4. All over 2 times 2. That equals 3 plus or minus. Remember, negative times a negative is always a positive. Minus 8 times 4 is 32. Okay. So if this is the case, notice that we're heading into negative territory. That'll be 23, -23. Horrible negative spot. -23. All over 4, and that's your imaginary solution. So let's find the solutions. X equals 3 plus I root, 3 plus I root 23 over 2 over 4, sorry, we can't divide any of them. 3 minus I root 23 over 4. Since I don't know the square root of 23, I'm leaving it. And then x equals -2. This one, we would do the same thing with synthetic division, but there are 5 solutions. We know 3 of them already. That means we're going to synthetic divide 3 times to end up with a quadratic, and then we're going to do quadratic formula because we expect it to be an imaginary solutions. Okay, because there's 1, 2, 3 that we see, that means there must be 2 that we cannot see. Okay, so let's do it. 1, 0, x to the 4th. Be careful with that. 1, -2, -12, -8. Now, it doesn't matter which one you start with, so I'm just going to go in order. That's my first one. Okay, and then we'll do synthetic division. Oops, 1 plus 1 is 2. This is -2, -4, +4, -8, +8. There we go. Okay, so this is x to the 4th, just as a heads up. And we're going to do synthetic division again. I'm not going to use 0. And we'll do x equals -1 as my second one. Okay, bring down the 1. There's your second remainder of 0. Now, just keeping track of where we're at, this was x to the 5th. Now we're at x to the 4th. Now we're at x cubed. I still have another 0 I can use. So I'm going to use x equals 2 now. Okay. So this was x cubed. That means this is x squared. X's and numbers. So that means I have x squared plus 4 equals 0. Okay. This, I get really excited when I see something like this because I don't have to do synthetic division or quadratic formula on this. This I can just solve. So I'm going to do it over here. X squared plus 4 equals to 0. I'm going to subtract 4 on both sides because I only have one x, so I can use inverse operations. I'm going to square root both sides. Make sure you don't lose that negative. Now I have x equals plus or minus the square root of negative 4. Remember, this is where the plus or minus comes in. Well, we know the square root of negative 4 is plus or minus 2i. So where are all of my solutions here? Let's list them out. I know I have x equals 2i, negative 2i, negative 1, and 2. Those are my 5 solutions for my, we call it quintic function. That concludes our lesson for today.